In this video, I'm going to tell you about facial gestures and how computers can recognize them. This is a very interesting application of low-dimensional representations. So one of the tools used a lot in animation these days is the motion capture. In this case, the motion capture is capturing the expression on the actor's face, and it's using that to control the avatar or to control the face of this animation. And the way that this is done is through these green dots, if you see them. And those green dots are tracked by a camera right here. And using that, we can basically track the contours of the face. But these dots that we have on the face, they might actually give us redundant information, because even though we have a lot of different facial expressions, really all of our facial expressions are controlled by the muscles of our face, and we have about 23 muscles, and so to control our face, and so that basically gives us the dimensionality that we need in order to track the face. So in effect, 23 markers will suffice to capture all expressions. So this idea was used by these researchers that wanted to add the ability to recognize facial gestures to a speech recognition system. So you have a speech recognition system here, and basically information from the facial gestures captured by the camera is added onto that, and helps with the recognition. And the numbers that they quote there is that if you use a simple model with 11 degrees of freedom, something like PCA, you can get a reasonably good representation for most facial gestures. And then if you add to them expressimes, meaning additional code words to detect extremal expressions, those you can think about as points or centroids. Okay, so you have kind of a mixture of low-dimensional representation using something like PCA, and then for some expressions that are extreme, you add some more centroids that to represent the data. So that's basically the model here. And this model helps improve the recognition ability of the speech. Another work in a different direction is work that was done to try to characterize faces using eigenvectors. So that was called eigenfaces. The researchers aligned carefully the faces of the pictures of faces that they had, and then they used PCA to find in what directions do the faces change the most. And an interesting thing here is that you can see the PCA that you get if you have intrapersonal, so you take one person and you just take a lot of different pictures of them. And this is the second one is extrapersonal, so differentiating between different people. So you see that the eigenvectors here represent more facial gestures, like smiling, and while here they represent things more like having or not having a mustache, or having heavier or lighter eyebrows. Here's another work that uses a different method called locally linear embedding to identify the dimensions at which this person is making faces. Okay, so this is kind of in the middle you have kind of the neutral position, and then you have here tilting to the right, making a pucker face, left tilt, smiling, and so on. Another work that is pre-computers really, but very influential in this area is that of Paul Elkman. Paul Elkman basically said that there are 7 archetypes of facial expression. Each one of them is expressing some very particular type of emotion, and that these are basically innate, so they don't change from person to person, even if the person comes from a completely different culture. So they're somehow genetically encoded rather than learned. And to prove that, Paul Ekman went to Papua New Guinea in 1963, to a place where Western people have not been ever, and he asked people to show their reaction to different kinds of sentences, and he basically shows that smiling is common to everybody, and is common to them, and also making a sad face is very common to everybody, and making an angry face is very common to also to these people in Papua New Guinea. So his claim was basically that this is not something that is special to us humans, but it's really something that comes right from our genetic forebears, and it is part of the way that we communicate with other creatures in our group. Okay, so here are the expressions of Paul Ekman, and here are the parallel expressions of these chimpanzees. Okay, so I'm going to tell you now about a company called Emotient that has basically used these technologies or methods that I was telling you about to actually create a system that can in real time recognize people's facial gestures. And that is a system that is very useful for advertisers when they want to, for instance, see how people react to their advertisements. It's also useful for law enforcement as lie detectors. So these are all good things, but of course, these kind of information that is coming from your face is not something that you really have much control of. And so there's a worry that people would basically be spying on you, unknowns to you, and basically finding out things about you that they can use against you. So I highly recommend that you use this link to go to a YouTube video about this subject, in which you can also see Dr. Paul Ekman describing how he developed these methods and why he is worried that they will be used in a bad way. So to summarize, facial gestures are innate. All apes use the same facial gestures. So it's not like basically something that we learn from our parents or from our peers, but it is something that is directly connected to our emotions. Faces can be modeled in different ways, PCA or using centroids, and in other ways. And any one of these models would give you a way to quantify the emotion that the person is expressing. Now, the ability to recognize facial gestures is becoming better and better. And so we have more and more systems that recognize not just who we are, but what we're feeling. And this can be a good thing in some cases, but it can also be used for bad, and we need to think about that. Okay, so that is what I wanted to tell you about facial gesture recognition, and I'll see you next time.